water for drinking. This would all have to be recycled a lot. And the technology in Star Trek is powered by things like fusion, perhaps fission. And fusion, like in real life, in Star Trek, uses a matter of fusing atoms or molecules of things like hydrogen with things like uranium. No, I forgot what it's called, but it is based off something in real life. We're working on fusion here in the 21st century. We'll have it by about 2050, so Star Trek Enterprise could still happen. It takes months, perhaps weeks at most, just if you were travelling from home to another planet which could be used for resources. Let's say it takes days to get outside of the solar system. We need to mine the solar system for resources, like hydrogen, especially if hydrogen fuel cells take on, which they have, but get on even more. Water in general, planet Earth needs a lot more water. I mean, I know 75% of Earth is covered in water, but 75%, that's water filled with sodium, and you could use water distilleries, but then there's just all the amount of water in general, and there'll be a lot of sodium remaining. So mine the solar system with things like water. If you have more than enough water, then you can separate the additional water into its elements of hydrogen and oxygen, which could be used for fuel, such as for cars or for spaceships, while oxygen could be used for air, which could be put into underwater domes, like an underwater like an underwater hydroponic garden, or put on spaceships. So yeah, the more often the NX Enterprise finds an asteroid, or more likely a comet filled with ice, or like ice water, the better. So then there's ships later on, like in the Star Trek original series, the 23rd century, 2260s odd. They've definitely improved the transporter technology. First, let's get back to the resources for a moment. If the average person needs, let's say you filled up a 10 by 10 by 3 meter room with food in the form of something as dense as butter, and it went through what Star Trek Enterprise has for a replicator, a protein resequencer. Let's say that's 3 meters by 10 meters by 10 meters equals 300 meters cubic. That's 300 times 7,000 kilocalories in a kilogram, 7 million kilocalories in a metric ton. So it's 300 times 7 million kilocalories. Divide by a crew of, let's lowball say 100. That means for any one person out of 100, that is 21 million kilocalories. Divided by 2,500 per day equals 8,400 days, which equals 23 years. And I just indirectly said sand for a moment with an S, a word beginning an N. Fuck. A word ending with S and a word beginning with and. I placed the word and, so I broke one of my personal grammar rules. That's for a room, if it was emptied out, if you had your own NX class Enterprise, if you had your own NX class Federation or pre-Federation as during the time of Starfleet, but not the United Federation of Planets, if you had an NX class starship, you could empty out half of its rooms. It's supposed to have 200 of them, which I call bullshit. Just from a 10 by 10 by 3 meter room, you could fit enough food, enough protein, if it has as dense as butter, for a 100 person crew for 23 years. Well, 28.01. Here's a bit of anti-endorsement.